everyone. Today we are going to discuss the important questions of second chapter, that is solutions. If you see the blueprint here, children, according to the blueprint, the solution chapter has got a weightage of around 7 mark. Here, 2 1-mark questions are going to appear from part A and 1 5-mark question is going to appear from part B. And let us solve the questions one by one now. As you all know, children, today we are going to discuss the chapter that is solutions. And here, let us first understand some basic concepts regarding solutions. What are solutions? If you consider here how the solution is going to be formed, these are the questions which are going to appear in our mind. And let me explain you first some of the basic concepts regarding solutions. How a solution gets formed here is, when a solute is mixed with solvent, a solution gets formed there. And you might be thinking of what is a solute and what is a solvent here. Let me get you an example here first. That is, a salt solution is prepared. How the salt solution is prepared? When 1 gram of a salt is mixed with 100 ml of water, there forms a salt solution. What is this 1 gram of salt and what is that 100 ml of water is going to act as? Here, if you consider a salt solution, children, salt solution is a solution, is in the solution state. Okay, if you consider 1 gram of a salt, that is going to act as the solute here, and the 100 ml of water is going to act as the solvent. Then what is a solute? Solute is a substance which we are going to add to the solvent is regarded as the solute. Then what is a solvent? Solvent is a component of the solution in which we are going to dissolve the solute. When a solute is mixed with the solvent, there forms a solution. Now let us discuss some of the important questions of the solutions one by one. If you see the first question here, define the term molarity and molality of a solution. They're asking you a question here. Define the term molarity and molality of a solution. What is this molality and molality means? Here, children, the concentration of a solution can be expressed in a number of ways. If you consider the concentration of the solution, that can be expressed even in the terms of molarity as well as molality. What is molarity? Molarity is defined as the number of moles of solute dissolved in a liter of solution. Now, a certain amount of solute now, ಎಷ್ಟು amount of solute na ಒಂದು liter of solution ಅಲ್ಲಿ dissolve ಮಾಡ್ತೀವೋ ಅದನ್ನ ನಾವು molarity ಅಂತ ಕರಿತೀವಿ. Then what is molality? Molality is defined as the number of moles of the solute dissolved in 1 kg of the solvent. And here, if you consider, children, the molarity is a volume dependent, and you can also consider it as temperature dependent term. But if you consider the molality is independent of the temperature. However, the temperature is going to change, it is not going to affect the molality of a solution, because the molality is not dependent on the volume, which is not going to be affected on changing the temperature. Hope you got to know about the first question. The first question is regarding defining the terms molarity and molality. This molality and molarity terms are used for expressing the concentration of a solution, where molarity is the number of moles of solute dissolved in 1 liter of the solution, and molality is defined as the number of moles of solute dissolved in 1 kg of the solvent. Now let us move towards the second question here, children. The second question is regarding state Henry's law and write its mathematical form. When you consider the solutions and also the solubility, what is solubility? Solubility is the capacity of a solution to maximize the solubility of a solute, that is regarded as the solubility, or you can also say the maximum amount of solute that can be dissolved in a solvent is regarded as solubility. And if you consider the solubility, there are a number of types of solubilities, like solubility of a gas in a liquid, solubility of a liquid in a liquid, solubility of a solid in a liquid. And here the Henry's law, whatever written here, if you consider, the Henry's law is going to appear in the case of solubility of a gas in a liquid, solubility of a gas in a solution. Okay. And here, if you consider the Henry's law states that at constant temperature, when you're going to keep the temperature constant, the solubility of a gas in a liquid is directly proportional to the pressure of the gas. Whatever the solubility of a gas in a liquid will be proportional to the pressure of the gas. Or we can also say like this: at constant temperature, when you're going to keep the temperature constant, the mole fraction, we are going to represent the mole fraction by writing the symbol. Okay. And here the mole fraction of the gas in a liquid is directly proportional to the pressure, and we can write the mathematical form of Henry's law as P is equal to KH into X. What is this X? X is going to indicate you the mole fraction, and P will be indicating you the pressure, and this KH is a Henry's law constant. Hope you got to know about the Henry's law and its mathematical form. Now let us move towards the next question here, children. The next question is, how solubility of a gas and liquid varies with temperature and pressure. How the solubility of a gas in a liquid is going to vary when you're going to vary the temperature as well as pressure. That is the question here. Okay, here we are dissolving the gaseous solute to the solution. One solution alli gaseous solute na tagondo add ಮಾಡ್ತಾ ಇದೀವಿ, such that the gaseous substance is going to act as the solute, and whatever the solution we are going to consider, that will be acting as the solvent here. Okay, and how the solubility of a gas in a liquid is going to vary when you are going to vary the temperature and pressure. Here, as you raise the temperature, if you consider the temperature, as you raise the temperature, ಏನಾಗುತ್ತೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು 100 ml ಅಷ್ಟು ವಾಟರ್ ತಗೊಂಡಿದ್ದೀರಾ, ಅದರಲ್ಲಿ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೈಟ್ರೋಜನ್ ಗ್ಯಾಸ್ ನ ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದೀರಾ. ಯು ಆರ್ ರೈಸಿಂಗ್ ದ ಟೆಂಪರೇಚರ್ ನ ರೈಸ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಸಚ್ ದಟ್ ಅಂದ್ರೆ ಹೇಗೆ ಟೆಂಪರೇಚರ್ ನ ರೈಸ್ ಮಾಡ್ತಿದ್ದೀರಾ, ಯು ಆರ್ heating up the mixture, whatever the solution mixture you have took, that you are heating up, heat ಮಾಡ್ತಿದ್ದೀರಾ. heat ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, ಅಲ್ಲಿ ಟೆಂಪರೇಚರ್ ರೈಸ್ ಆಗುತ್ತೆ. as the temperature raises, the gaseous solute particles will be getting converted into the vapor phase ಗೆ ಅದು ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆಗ ಅಲ್ಲಿ ಸಾಲಿಬಿಲಿಟಿ ಏನಾಗ್ತಾ ಇದೆ, the solubility is getting decreased, ಕಮ್ಮಿ ಆಗ್ತಾ ಇದೆ. ಯಾಕೆ ಕಮ್ಮಿ ಆಗ್ತಾ ಇದೆ? because the gaseous solutes are not getting dissolved in the solution, they are escaping to the vapor phase. phase ಗೆ ಅದು escape ಆಗ್ತಾ ಇರೋ ಕಾರಣಕ್ಕೆ, as you raise the temperature, the solubility of a gas in liquid decreases. as you decrease the temperature, the solubility of a gas is going to be increased. This is how the solubility of a gas in liquid is going to vary with temperature. Now let us consider the pressure. How the solubility of a gas in a liquid is going to vary with pressure. Let me explain you this, children. Here you are applying the force on the solution. Which solution? If you have prepared a solution by dissolving the gaseous solute particles in a solution, ಒಂದು ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲಿ gaseous solute particles ಡಿಸಾಲ್ವ್ ಮಾಡಿದ್ದೀರಾ, ಡಿಸಾಲ್ವ್ ಮಾಡಿ ಒಂದು ಸೊಲ್ಯೂಷನ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡಿದ್ದೀರಾ. here you are increasing the temperature, pressure ನ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀರಾ ಸೊಲ್ಯೂಷನ್ ಮೇಲೆ. pressure ಅಪ್ಲೈ ಮಾಡಿದಾಗ the gaseous solute particles present in the solvent are going to be compressed ಆಗುತ್ತೆ. compressed ಅಂದ್ರೆ they are made to be there in the solvent itself. ಆ ಸಾಲ್ವೆಂಟ್ ಅಲ್ಲೇ ಇರೋ ಹಂಗೆ ಆಗುತ್ತೆ. if such is the condition, the solubility of a gas is going to increase there, because the gaseous particles are not getting converted into the vapor state. As in the case of temperature, they are not getting converted into the vapor state. They are made to be in the solution itself. If such is a condition, when you are going to increase the pressure na ಜಾಸ್ತಿ ಮಾಡ್ತಿದ್ದಂಗೆನೆ the solubility of a gas in a liquid is going to increase. As you decrease the pressure, the solubility of a gas in a liquid is going to decrease. This is how the solubility of a gas in a liquid is going to vary with temperature and as well as pressure. Now let us head towards the next question, children. The next question is regarding state Raoult's law for liquid mixtures. Here we are talking about a solute is mixed with a solvent, where the solute as well as solvent are in the liquid state itself. And here we are talking about the solubility of a liquid in liquid. Liquid ಅನ್ನೋ ಒಂದು solute component liquid state ಅಲ್ಲಿ ಇರುವಂತ ಒಂದು solvent component ಜೊತೆ ಮಿಕ್ಸ್ ಆದಾಗ solubility ಹಿಂಗಾಗತ್ತೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ನಾವು ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿದೀವಿ. When we are going to discuss the solubility of a liquid in a liquid, here comes the application of the Raoult's law. Raoult's law ದು application ಇಲ್ಲಿ ಬರುತ್ತೆ. According to the Raoult's law, it states that for a solution of volatile liquids, volatile andre escaping liquids na ನೀವು consider ಮಾಡಿದ್ರೆ, the partial vapor pressure of each component at a given temperature, and at any given temperature you can consider, will be directly proportional to the mole fraction of that component in the solution. It is almost similar to the Henry's law, but in the case of Henry's law we are going to consider the solubility of a gas in a liquid, but in the case of Raoult's law we are going to consider the solubility of liquid in a liquid. And even here we are also going to consider the solution of volatile liquids. Volatile andre, as I already told you, that escapable liquids ನಾವು consider ಮಾಡಿದ್ರೆ, the partial vapor pressure of each component at a particular temperature will be directly proportional to its mole fraction. Now children, hope you got to know about the fourth question. Let us head towards the next question now. The next question is regarding give any two differences between ideal and non-ideal solutions. And here we are talking about the two components which are in the liquid state. Okay, here we are talking about the binary mixture you can consider. And when we are going to consider the liquid in liquid, a solution which contains a liquid in liquid, a solute which is in the liquid state, as well as a solvent which is also in the liquid state. Here there are two types of solutions. One is the ideal solution, the other one is a non-ideal solution. And if you consider the ideal solutions, the ideal solutions are those solutions which obey the Raoult's law. Raoult's law na obey madutte. What does Raoult's law states? As I already mentioned you, for any two volatile liquids, if you consider the vapor pressure or the partial pressure of a component is directly proportional to its mole fraction at a given temperature. Here those solutions which obey the Raoult's law are considered as ideal solutions. The example for an ideal solution here is N-hexane mixed with N-heptane. Here if you consider both the components are in the liquid state, this is an example for an ideal solution which obeys the Raoult's law. And if you consider the other points under the ideal solution, the change in volume of mixing will be equal to 0. Here children, let me explain you. Here I am going to consider, let me explain you by taking one example. Here I am going to consider two solutions. Here the solutions na consider martini. One is the solution A, the other one is the solution B. Okay, here I am going to mix the components, and here I am taking 10 ml of solution A and 10 ml of solution B. When I'm going to mix these two solutions, the final volume of a solution formed here will be 20 ml. Is there any change in the volume after mixing those two solutions? No. Here, that is what we are saying. The change in volume on mixing will be equal to 0. Okay. And the next point under the solutions here is the change in enthalpy on mixing will also be equal to 0. That is, when you are going to mix the two components which are in the liquid state in order to form a solution, the change in enthalpy will also be equal to 0 because there is no change in enthalpy after mixing those two components in order to form a solution. If these conditions are obeyed, then such solutions are regarded as ideal solutions. Now let us consider the non-ideal solutions. If you consider the non-ideal solutions, the solutions which does not obey the Raoult's law are called the non-ideal solutions. The best example for that will be phenol mixed with aniline is an example for the solution which are not going to obey the Raoult's law. That is non-ideal solutions you can consider. And here, children, the change in enthalpy of mixing will not be equal to 0. 0 ge equal iralla, as well as the change in enthalpy of mixing will not be equal to 0, and the change in volume of mixing will also be not equal to 0. That is, for example, here I am going to consider two components. One is the component A, the other is the component B. And here I am mixing component A with component B. Here I took 10 ml of component A and the 10 ml of component B. After mixing these two components, I have got one solution there. And if I measure the volume of the resultant solution, the volume of that solution will not be equal to exactly 20 ml. It is going to be either 19.9 ml or 20.1 ml. That is indicating you that there is a change in volume on mixing those two components, which is telling you that the change in volume on mixing the solution is not equal to 0. There is some change in mixing and the change in volume on mixing those two solutions. And here, if you consider the change in enthalpy upon mixing those two components, even here, that will not be equal to 0. The enthalpy is going to change. The enthalpy upon mixing those two solutions is going to have some other value rather than 0. Those solutions which are going to obey these conditions are regarded as non-ideal solutions, and you can write these points of differences for both the ideal as well as non-ideal solutions. Now, children, let us consider the next question now. The next question is regarding, the sixth question is regarding define boiling point elevation constant or molar elevation constant or ubuloscopic constant. Mention its SI unit. SI unit and the international standard unit. What is boiling point elevation constant? Boiling point elevation constant and the name in the kuda karitive, as well as molar elevation constant and the kuda karitive, and that can also be regarded as ubuloscopic constant. Then what is that term is going to indicate you? That term is regarded as the elevation in boiling point. It is the elevation in boiling point when the molality of the solution is going to be 1. It is going to be unity. When the concentration of that solution, when we are going to express the concentration of that solution in terms of molality, if the molality has got unit value, then the elevation in boiling point of such a solution is regarded as boiling point elevation constant or molar elevation constant or ubuloscopic constant. and it has got a SI unit, that is Kelvin kg per mole is the unit for molar elevation constant. Now let us move towards the next question. The next question is almost similar to this question, but here we are going to use the freezing point term. Okay, the question is define freezing point depression constant or molar depression constant or cryoscopic constant and mention its SI unit. Here makla temperature enagutte, freezing point enagutte, depress agutte illi. Here the depression in freezing point when the molality of the solution is going to be unity. A ಒಂದು solution the molality 1 ಇರಬೇಕಾದ್ರೆ then the depression in freezing point of such a solution is regarded as freezing point depression constant. That can also be regarded as molar depression constant or the cryoscopic constant. And even this has a same unit as that of elevation ubuloscopic constant, that is Kelvin kg per mole is a unit for cryoscopic constant. Now children, let us move towards the next question. The next question is regarding define isotonic solution. Isotonic solution andre enu anta kelidare. Magla, when you are going to consider the solutions, there are three types of solutions we can see. One is the hypotonic solution, hypertonic solution. The next one is the isotonic solution. What is hypotonic solution? Hypotonic andre the solution which has lower osmotic pressure, that is known as hypotonic solution. Hypertonic solution andre the solution which has more osmotic pressure, that is regarded as hypertonic solution. Then what is isotonic solution? The two solutions having same osmotic pressure. The two solutions having the same osmotic pressure are regarded as the isotonic solutions at a given temperature. At any of the, at a particular temperature we can see. At a particular temperature, if the two solutions have got the same osmotic pressure, then such solutions are regarded as isotonic solutions. Okay, and here children, I have used when I was telling you regarding hypotonic, hypertonic as well as isotonic solutions, I have used a word that is osmotic pressure. What is osmotic pressure? Let me tell you that osmotic pressure andre the force which makes the movement of the solvent particles from the solution, that is regarded as osmotic pressure. ಅಂದ್ರೆ ಆ ಸಾಲ್ವೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಸೊಲ್ಯೂಷನ್ ಇಂದ ಮೂವ್ ಆಗ್ಲಿಕ್ಕೆ ಏನೆಲ್ಲ ಫೋರ್ಸ್ ಅಲ್ಲಿ ಬೇಕಾಗುತ್ತೋ ಅದನ್ನ ನಾವು ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಅಂತ ಕರಿತೀವಿ. ಈಗ ಐಸೋಟಾನಿಕ್ ಸೊಲ್ಯೂಷನ್ಸ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಗೊತ್ತಾಯ್ತು ಅನ್ಕೊಂತೀನಿ. ದ ಟೂ ಸೊಲ್ಯೂಷನ್ಸ್ ಹ್ಯಾವಿಂಗ್ same osmotic pressure at a given temperature are regarded as isotonic solutions. Further, the question continues, children. If you see the question here, what happens when blood cell is dipped in a solution containing more than normal saline concentration? And here, if you think, children, the blood cell is in isotonic with normal saline solution, and the normal saline solution jotege blood cell isotonic agide. Isotonic agide andre blood cell ige matte normal saline concentration andre normal saline solution ige ಎರಡಕ್ಕೂ ಕೂಡ same osmotic pressure ide. Such solutions are called isotonic solutions. You know that. Okay, and here comes the application of osmosis. What is osmosis? Osmosis andre makla the process of movement of solvent molecules from a solution of lower concentration to the higher concentration through a semi-permeable membrane, that is regarded as osmosis. ಆಸ್ಮೋಸಿಸ್ ಅಂತ ನಾವ್ ಅದನ್ನ ಕರಿತೀವಿ. ಅಂಡ್ ಹಿಯರ್ ನಾನು ಆಗ್ಲೇ ಮೆನ್ಷನ್ ಮಾಡಿದೆ, ಬ್ಲಡ್ ಸೆಲ್ ನಾರ್ಮಲ್ ಸೆಲೈನ್ ಸೊಲ್ಯೂಷನ್ ಜೊತೆಗೆ ಐಸೋಟಾನಿಕ್ ಆಗಿದೆ. ಐಸೋಟಾನಿಕ್ ಆಗಿದೆ ನಾವು ಎರಡೂ ಸೊಲ್ಯೂಷನ್ಸ್ ಗೆ, ಆ ಬ್ಲಡ್ ಸೆಲ್ ಗೆ ಮತ್ತೆ ನಾರ್ಮಲ್ ಸೆಲೈನ್ ಸೊಲ್ಯೂಷನ್ ಗೆ ಸೇಮ್ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಇದೆ. ಅಂಡ್ ಸೇಮ್ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್ ಇರ್ಬೇಕಾದ್ರೆ ಯಾವುದೇ ತರದ ಆಸ್ಮೋಸಿಸ್ ಅನ್ನೋ ಪ್ರಾಸೆಸ್ ಅಲ್ಲಿ ಆಗಲ್ಲ. ಯಾಕಾಗಲ್ಲ? ಬಿಕಾಸ್ ಬೋತ್ ದ ಸೊಲ್ಯೂಷನ್ಸ್ ಹ್ಯಾವ್ ಗಾಟ್ ದಿ ಸೇಮ್ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಸೇಮ್ ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್. Ega matla, the question is saying that what happens when a blood cell is dipped in a solution containing more than normal saline concentration. Normal saline concentration ginta ಜಾಸ್ತಿ concentration ಇರುವಂತ solution ಅಲ್ಲಿ ನಾವು blood cell ನ dip ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? What actually happens there? That is the question. ಏನಾಗುತ್ತೆ? As I already told you, the application of osmosis comes here. What is osmosis? As I already mentioned you, the process of movement of the solvent molecules from a lower concentration to the higher concentration through a semi-permeable membrane. That is known as osmosis. ಈಗ ಇಲ್ಲೇನಾಗತ್ತೆ? ಬ್ಲಡ್ ಸೆಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಇದೆ, ನಾರ್ಮಲ್ ಸೆಲೈನ್ ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಇದೆ ಅನ್ಬೇಕಾದ್ರೆ there is a movement of solvent molecules from a lower concentrated solution to a higher concentration solution. Aga solvent particles are on the blood cell in them remove aitu anta helidaga the blood cell is going to shrink. Blood cell enagutte complete agi shrink agutte. Suppose makla illi what happens if the question is like this: what happens when the blood cell is dipped in a solution containing less than normal saline concentration? Normal saline concentration ginta kammi irbekadre ಆ ಒಂದು solution ಅಲ್ಲಿ blood cell ನ dip ಮಾಡಿದಾಗ actually ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈಗ ನಾರ್ಮಲ್ ಸೆಲೈನ್ ಸೊಲ್ಯೂಷನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಇದೆ ಕಂಪೇರ್ಡ್ ಟು ದ ಬ್ಲಡ್ ಸೆಲ್. ಆಗ ಏನಾಗುತ್ತೆ? ಮೂವ್ಮೆಂಟ್ ಆಫ್ ದಿ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಲ್ ಬಿ ಟೇಕಿಂಗ್ ಪ್ಲೇಸ್ ಫ್ರಮ್ ಅ ಲೆಸ್ಸರ್ ಲೋವರ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಟು ಅ ಹೈಯರ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್. ಆಗ ಸಾಲ್ವೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ saline solution in the blood cell ಗೆ move ಆಗುತ್ತೆ such that the blood cell is going to bulge in the size. The size of the blood cell is going to increase due to the movement of the solvent molecules. Hope you got to know about this question. Now let us move towards the next question. The next question is, what is reverse osmosis? Mention one practical utility. ಅದು practical application ಹೇಳಿ ಅಥವಾ practical use ಹೇಳಿ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. What is reverse osmosis? ಈಗ ನಾನು osmosis ಅಂತ already ಹೇಳಿದೆ ಏನು ಅಂತ. ಈಗ reverse to that osmosis is what is regarded as reverse osmosis. Okay, let me explain you that, children. When a pressure greater than the osmotic pressure is applied to the solution side, solution side ಗೆ osmotic pressure ಗಿಂತ ಜಾಸ್ತಿ ಇರುವಂತ ಪ್ರೆಷರ್ ನ ನಾವು ಅಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿದಾಗ the movement of the solvent molecules will be taken back from the solution to the solvent. That is regarded as the process called reverse osmosis. ಈ reverse osmosis ಅನ್ನೋ process ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಮಕ್ಕಳ, the best example for this will be ನೀವು ಮನೇಲಿ ಯೂಶುವಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತೀರಾ for the drinking water. Drinking water ಬೇಕು ಅಂತ ಹೇಳಿದಾಗ, ನಮ್ಗೆ ಗುಡ್ ಕ್ವಾಲಿಟಿ ಇರುವಂತ ಡ್ರಿಂಕಿಂಗ್ ವಾಟರ್ ಬೇಕು ಅಂತ ಹೇಳಿದಾಗ we are going to use a water purifiers there. Water purifiers ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಲ್ಲಿ RO ಪ್ಲಾಂಟ್ ಅಂತ ನಾವಲ್ಲಿ ಆ ಒಂದು ಪ್ಲಾಂಟ್ ನಾವಲ್ಲಿ ಹಾಕಿರ್ತೀವಿ. what does it mean? ಅದು ಏನಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ? what is that process that is taking place there? It is actually the reverse osmosis process which is applied there, which helps in the purification of the drinking water. Drinking water purify ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡುತ್ತೆ. That is what is also used in the case of desalination of seawater. The seawater will be containing this highly concentrated solution. andre which contains more number of electrolytes. We need to convert that into a drinking water. ಆ ಒಂದು sea water ಇಂದ salinity ನ ನಾವು remove ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದಾಗ we are going to apply the reverse osmosis process here. This is what is regarded as reverse osmosis and one of the practical utility of that reverse osmosis. Now children, let us move towards the properties of the solutions. Here if you consider the properties of the solutions, there is a colligative properties of the solutions. There are 4 colligative properties of a solution. They are relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and finally osmotic pressure. And here makla definitely you are going to get a problem regarding any of the colligative property that I have already mentioned you. And let us see the equations involved with every colligative property. Here there is a problem regarding osmotic pressure. And if you consider the formula here, the osmotic pressure has got a formula that is pi is equal to WRT divided by M2 into V. What is this indicating? This pi is going to represent you the osmotic pressure of the solution. Okay, and this W is the mass of the solute. Solute the mass na ನಾವು W ಅಂತ ಬರ್ದು represent ಮಾಡ್ತೀವಿ. And as you all know that R is a universal gas constant. Universal gas constant has got a value that is 0.083 liter bar per Kelvin. The universal gas constant value is going to be dependent on the unit. ಅದ್ರದ್ದು ಏನ್ ಯೂನಿಟ್ ಇರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಬಟ್ ಡೆಫಿನೆಟ್ಲಿ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೆನ್ಷನ್ ಯು ದ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ, ಯೂನಿವರ್ಸಲ್ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂನ ಅವರು ಮೆನ್ಷನ್ ಮಾಡಿರ್ತಾರೆ while solving the problem. And what is this T? T represents you the temperature at which the solution is getting formed. ಅದನ್ನ ನಾವಿಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Then what is this M2? M2 ಏನ indicate ಮಾಡುತ್ತೆ? M will be indicating you the molar mass or the molecular mass of the solute. Solute the molecular mass ಹೇಳ್ತಿದ್ದಾರೆ ಅಂತ ನಮ್ಗೆ ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ? Here they have indicated you the digit 2 ಅನ್ನೋ digit ನ ಇಲ್ಲಿ ಬರ್ದಿದ್ದಾರೆ. That indicates you that 2 is for the solute, and if they represent 1 ಅನ್ನೋ ಒಂದು digit ನ ಮೆನ್ಷನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ that will be indicating you the solvent ನ indicate ಮಾಡುತ್ತೆ. Then what is this V? V stands for volume. Okay, and let us solve one problem regarding the osmotic pressure. The problem is like this: if 1.71 gram of a sugar having the molecular mass 342 is dissolved in 500 cm cube of a solution. 500 cm cube of a solution alli dissolve madidare at a temperature of 300 Kelvin. They're asking you to find out the osmotic pressure of the solution, and they have provided you with the universal gas constant. Okay, let us write the given data first. What is this R? R is a universal constant, universal gas constant. We have provided you with the value. Okay, then what they are saying, 1.71 gram of the sugar is dissolved in 500 cm cube of the solution. The substance which we are going to add to the solvent is regarded as solute. A solute the weight na avaru mention madidare. They have mentioned you with the gram alli avaru mention madidare andre they have provided you with the weight of the solute, that is W2 is equal to 1.71 gram. And they also provided you with the molecular mass of that solute. The molar mass of that solute is 342 gram per mole anta ಹೇಳ್ತಿದ್ದಾರೆ. That is M2 they have provided you, and they are saying you that the reaction, the solution is formed at 300 Kelvin. So we are going to mention the temperature as 300 Kelvin. And they also provided you with the volume. Volume nu kuda avaru provide madidare. ಎಷ್ಟು volume anta ಹೇಳ್ತಿದ್ದಾರೆ. They are telling you that it is going to be around 500 cm cube. 500 cm cube ಅಷ್ಟು volume ಇದೆ. Makla, one thing you need to know here, whenever the volume is mentioned in terms of liter or meter cube, as such you are going to substitute the value in the case of volume. But whenever they are going to mention you the volume in terms of cm cube alli athwa milliliter alli volume na mention madidare andre, you need to convert that volume to a liter or meter cube ಗೆ convert ಮಾಡ್ಕೊಂಡು ಆಮೇಲೆ substitute ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. And we have applied the formula here. The problem is regarding osmotic pressure, so we have applied the osmotic pressure formula here, that is telling you that pi is equal to WRT divided by M2 into V. What is W? W is 1.71. Then what is R? R value is 0.083. Then what is T? The temperature is 300 Kelvin. Then what is M2? M2 is 342. Then what is the volume? As I already mentioned you, cm cube ಅಲ್ಲಿ ಇರೋದನ್ನ ಅವರು ಮೀಟರ್ ಕ್ಯೂಬ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂತಿದ್ದಾರೆ. ಸೊ 500 cm cube ಇದ್ದಿದ್ದು ಏನಾಗುತ್ತೆ ಮೀಟರ್ ಕ್ಯೂಬ್ ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ 0.5 meter cube ಆಗುತ್ತೆ. Okay, that is what we mentioned here. When you are going to solve this problem, you are going to get the osmotic pressure of a solution to be as 0.249 bar. Okay, the unit for the pressure here in this problem is bar. Okay, the osmotic pressure of the solution is 0.249 bar. Hope you got to know about how to solve a problem regarding the osmotic pressure. And here, children, let us consider the next problem. The next problem is regarding the depression in freezing point. And if you see the formula for depression in freezing point, it is found to be M2 is equal to Kf into W2 into 1000 divided by delta Tf into W1. What are these things are going to indicate you? Let me tell you that M2 andre, it is the molar mass of the solute. Kf andre, it is the depression in freezing point constant, or you can also regard it as cryoscopic constant. W2 andre, it is the mass of the solute into 1000 divided by delta Tf andre, makla delta Tf is the depression in freezing point, and W1 andre, it is the mass of the solvent. Now let us see the problem regarding this formula, that is 1 gram of a non-volatile non-electrolyte solute dissolved in 50 gram of benzene has lowered the freezing point of the benzene by 0.4 Kelvin. Find the molar mass of the solute. And they have provided you with the Kf, that is cryoscopic constant for the benzene. They have provided you. It is found to be 5.12 Kelvin kg per mole. Now let us mention the given data here. Here they have provided you with the Kf. It is found to be 5.12 Kelvin kg per mole. And they are saying you that 1 gram of non-electrolyte solute is dissolved in 50 gram of benzene. Here 1 gram of non-electrolyte is going to act as a solute, and the benzene is acting as the solvent. They have provided you with the weight of both the solute as well as the solvent. The weight of solute is found to be 1 gram, and the mass of the solvent is found to be 50 gram. And they also provided you that it has been lowered the freezing point na lower madide by 0.4 Kelvin. That is delta Tf kottidare. The delta Tf is 0.4 Kelvin. And they are asking you to find out the molar mass of the solute. And if we substitute the given data in the formula, the Kf is 5.12, W2 is 1, into 1000 divided by delta TF is 0.4 and the W1 is 50. And when we substitute and solve the problem, the molar mass of the solute is found to be 256 gram per mole. Hope you got to know how to solve a problem regarding depression and freezing point. Now let us move towards the next question. The next question is regarding the 13th question. If you see, the 13th question is regarding the relative lowering of vapor pressure. And the formula for the relative lowering of vapor pressure is P naught minus P. Here, if you consider, it is P naught minus P divided by P naught is equal to W2 into M1 divided by W1 into M2. What does this P naught is indicating? P andre makla, that is going to indicate you the pressure na indicate marutte. W andre you know that is it is going to indicate you the mass. M andre makla, that is going to indicate you the molar mass. But they have provided you with the digits here, W2, W1, M2, M1 anta provide madidare. As I already mentioned you, 2 represents the solute and 1 is going to represent the solvent. Here P naught andre vapor pressure of the pure solvent. P andre vapor pressure of the solution. Solution andre how the solution will be formed. After dissolving certain amount of solute in the solvent, there forms a solution and this P is going to represent you the vapor pressure of the solution. W2 andre that is mass of the solute. W1 andre mass of the solvent. M1 andre molecular mass of the solvent. M2 andre molecular mass of the solute. And here, let us solve one problem regarding the relative lowering of vapor pressure. They are telling you that at 298 Kelvin, at a standard temperature, the vapor pressure of water is found to be 23.75 millimoles of mercury. Calculate the vapor pressure of these at the same temperature over 5% of aqueous solution of urea, and they have provided you with the molar mass of the urea. It is found to be 60 gram per mole. Let us see the given data here. They have provided you with the P naught andre vapor pressure of water enu anta heltidare. It is found to be 23.75 millimoles of mercury, and they also provided you with the molar mass of the solvent. Molar mass of the solvent andre here water is acting as a solvent. Water the molar mass estimated, it is found to be 18 gram per mole. And they are saying you that they are dissolving the urea in water. Then what does this urea is acting as? Urea is acting as the solute here. The weight of the solute is found to be 5% anta helidre. It is 5 gram. 5 gram as to urea na avaru water alli dissolve madidare. Then weight of the urea will be 5 gram. Then what is the weight of the we can consider what is the weight of the solvent here. Solvent the weight ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ 5% ಅಷ್ಟು ಯೂರಿಯಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ 100% solution ಅಲ್ಲಿ remaining amount will be of the solvent, that is 95% ಅಷ್ಟು water ಇಲ್ಲಿ present ಇದೆ, that is the mass of the water will be 95 gram. And here we are going to use the formula, the relative lowering of vapor pressure formula here, that is P naught minus P divided by P naught is equal to W2 into M1 divided by W1 into M2. When we are going to substitute the given data here, and we need to find out the pressure of the water, pressure of the solution formed here, and the pressure of the vapor pressure of the solution is found to be 23.37 millimoles of mercury. Hope you got to know about how to solve the problem regarding relative lowering of vapor pressure. Now let us concentrate regarding the last qualitative property, that is elevation in boiling point. And if you consider the formula for elevation in boiling point, it is found to be like this: delta TB is equal to Kb into W2 into 1000 here, children. They forgot to write 10 here, into 1000 divided by M2 into W1. What is this delta TB is representing? Delta TB andre makla elevation and boiling point. KB andre ubuloscopic constant. W2 andre mass of the solute into 1000 divided by M2 andre molar mass of the solute. W1 andre mass of the solvent. Let us solve one problem regarding this. They are telling you that the boiling point of benzene is found to be 353.23 Kelvin. Pure benzene ನೀವು ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಅದರದ್ದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ 353.23 ಕೆಲ್ವಿನ್ ಇರುತ್ತೆ. When 1.8 gram of a non-volatile solute was dissolved in 90 gram of benzene. Here, which is acting as the solute and which is acting as the solvent? They are telling you that 1.8 gram of non-volatile solute na tagdu 90 gram of benzene alli add ಮಾಡ್ತಿದ್ದೀರಾ ಅಂದ್ರೆ this non-volatile substance is going to act as the solute and the 90 gram of benzene is acting as the solvent. And in this sentence they have provided you with the mass of the solute as well as the mass of the solvent. The mass of the solute is found to be 1.8 gram and the mass of the solvent is found to be 90 gram. And they are telling you that the boiling point is raised andre pure benzene the boiling point to 353.23 Kelvin ittu, but so and so solute na so and so solvent alli dissolve ಮಾಡಿ ಆದಮೇಲೆ boiling point to raise agide. ಎಷ್ಟು raise agide? It has been raised to 354.11 Kelvin. So they are asking you to calculate the molar mass of the solute and they have provided you with the ubuloscopic constant of the benzene. It is found to be 2.53 Kelvin kg per mole. And if we substitute the given data in the formula is found to be delta TB is equal to Kb into W2 into 1000 divided by M2 into W1. If you substitute the given data here and if you find out the molecular mass of the solute, it is found to be 58 gram per mole. Hope you got to know about how to solve the problem regarding the 4 colligative properties. As I already mentioned you children, problem is going to surely appear from any of the colligative property. And children, here with this you came to know about how what are the important questions in the case of the chapter solutions and the problems regarding the colligative properties. Thank you all for the session. Thank you.